This conference will now be recorded.
Hi, good evening. So, as we discussed, right? So, today we'll be starting with state manipulation. So, let us discuss what is manipulation, like what we are going to discuss in this topic. What are the categories we have in the state manipulation, and when we have to use some disaster recovery, and then state commands, refresh, state locking, remote state storage, okay, resource target. So how will you handle these situations and what scenarios, and how will helpful for you when you're handling some large infrastructure on the target provider? So first of all, state locking in the sense we are working on the state file. Okay, so till now, if you recall your topics, what we have discussed, if you look at this variables or anything, okay, you can see here, right? There are some state files. Let me look at the task. I think I don't have here. Let me go to the day one operations. I guess I have it. So you can see there is a Terraform state file. So this is the file which I am storing in my local system. Okay, that's fine, well and good. If you are the only person, that is fine. Okay, so you will be managing this entire infrastructure from A to Z, from creation, from update and deletion, everything you will be doing from this workstation. But what about real time? Is this the way that we follow in the real time to do the actions from your workstation to the Terraform target provider? No, this is not the case, right? What we will do is nothing but we maintain our particular Terraform configuration files in the GitHub repository or Bitbucket or GitLab or any version control system like Azure code commit or AWS code commit and Azure, we have repos, right? So there are different kind of providers what they are providing to store your any files like configuration files, any some particular code or something like that. Those are called as version control system. Okay, so when you are using this version control system, it is better you push your code there and use some CI/CD operation. Okay, so where it will create some workstation and run the Terraform commands from there, or it will create some container, or on Kubernetes it will create some pod and it will do the necessary task. So you are not creating the infrastructure, your CI/CD operations are doing it. Okay, so when you're doing it, the problem is even that particular server is disaster, something went wrong, your Terraform state file will not be available, right? So then we need some solution where we need to store our state of our current state of our target provider in some particular location, where in such a way that if something goes wrong, I can restore that particular Terraform state file and I can do the actions from there. Okay, so I don't want to store in some particular agent or in some particular CI/CD target node or in my workstation or some other developer workstation. So we want to store wherever we have run the actions from our local machine or from our CI/CD pipeline or from my GitHub actions or from my GitLab CI or Azure pipeline or AWS code commit, what sorry code, what do we say, code pipeline, from wherever it is I ran, my state file has to be stored in a remote location. Okay, so the benefit is we are maintaining a centralized state file so that we will know the current state of our particular infrastructure, and the benefit of using that is nothing but you can add a versioning to it. Versioning in the sense, any change which has happened to this particular file will be created a version, means it will create some version to that particular state file. So the latest file will have the current state and the previous file will have the previous state of that particular infrastructure. So you can track and you can restore to that particular state at any point of time whatever you want. Okay, the benefit of having this file is you can restore your cluster to that particular cluster or your infrastructure to that particular state. Okay, so that is a benefit of using it. So Now how I can store this particular state file in a remote location? Let's say I am working on AWS. Okay,
Hello.
sorry.
So, so I have a question here. Uh, so if you put this file in Git or somewhere in the remote location, let's say, if both are working, we don't know, right? It will lead to confusion, right? Like it will.
How come? See, if you are executing the commands, your state file will be the same, right? Even if you run from this machine, or if you run from your machine, or from the CI/CD pipeline, you write your configuration file, but your state file is in the centralized location. It will not store in the local machine.
But if two people are pushing, I mean, two people are trying to access the file from, if person A,
Ha.
person B is accessing.
Then there is another concept called state locking, which means that if one person is doing some action on this particular file, means one particular process has trying to open this file. If another process is trying to open this file, it will lock it. It will not open that. Okay. So that is
Oh,
related to state locking. So we are
okay.
talking about a remote state storage right now. Okay, when we come across that, and then I will be talking like when multiple people are working on Terraform workflow, so how your state file will get updated, or if I want to log this file, how I can handle that. Okay, that is called as Terraform state logging. Okay, so now our intention is to store the Terraform state file in a remote location, so that tomorrow if my system is crashed, my workstation is crashed, I don't need to worry. Okay, I have my Terraform state file. Okay, I can import the resources, and I can create the configuration files. I can do a lot more other stuffs. Okay, so let us see that. That is called as state disaster recovery, which I'm talking about. So we will be discussing multiple things in this particular topic, and we will see if we have any questions we can discuss. Okay, but we are too early to talk about this. What are the different approaches we have? But let us see the approaches one by one. Okay, and then we will come to a conclusion, like what are the things that are not provided by your Terraform state. Okay, manipulation. So now let me create a new directory called mkdir state. Okay, I'm creating a separate directory like state manipulation. Let's go with the topic wise. So here you can see Terraform state storage, and we will be talking about, and Terraform state locking. Locking I have not explained yet. Let us see that later. But Terraform state storage is something where Terraform state backends works on three principles like state storage, state locking, and operations. Okay, so three principles in the sense state storage in this is where you want to store your Terraform state file. That is backend storage. So what is your backend storage? Is it S3 bucket? If it is AWS, is it Azure storage? If it you are using Azure, is it Kubernetes secret or config map? So you have to decide based on target provider what you are using. Okay, and then state locking, which we are talking about, right? When multiple people are trying to run the Terraform workflow commands, if one person is already trying to do some changes on the infrastructure, if second person in the sense a process is trying to do some actions on that particular state file, it will log that. It will not do any actions, it will reject. Okay, so how it will reject, I will show you some output somewhere. I captured it actually. I can show you that. Okay, maybe in state logging I have captured the output. You can see here, see this output. This is how the error message will be shown. The changes in the GAN has been detected and require the existing state. I think, yeah, just a second. Yeah, here it is. Sorry, that is a wrong one. Here you can see. Okay, it is telling you that one or more parameters values are invalid, missing the key state locking in the item, and the provider Terraform acquires a state locking to protect the state being written by multiple users at the same time. See this particular statement. Terraform acquires a state lock to protect the state from being written by multiple users at the same time. To resolve this issue above, which I got earlier, like above issue what you are saying, it is telling you that try again. For most commands, you can disable the locking with the lock is equal to false. Still, you can control that. Still, I can, what do you say, bypass that particular state locking. That is called as hyphen lock is equal to false. But it is not at all recommended to do. Okay, yes, we can do it, but still it is not recommended to use. But by default, when multiple people are working or multiple process is trying to open the file, it will not allow you. This is how it will lock the file and it will show you the error message. Okay, so this is the output which
By
I've
default
captured
it
in
is
this.
locked, right? By default it is locked, correct?
By default it is,
Locked or unlocked by
yeah, it
default.
is locked. It will be locked. How it will unlock? By default it will lock the file, right?
Okay. But if you want to
Until that
unlock, what is the
process,
pattern?
until that process is done, it will unlock. After the process has been completed, right, it will unlock. Again, if you are running
Oh,
the state file and if someone is trying to run a command, okay, again it will lock the file until that process is done. Once the process is done, at the end it will show you that it is unlocking the file. Okay, yeah. So, and then that is called as locking file storage in a shared location. Operations and runs in the sense create, update, delete, destroy resources on a respective provider. So whatever you do, whether you create a resource or whether you read the resource or whether you update the resource or you destroy the resource, everything will be stored in the state file, right? So that is the reason why we use this particular state files, right? So it looks like this, right? So if you start looking at this, this is one of the image which I've created. Terraform state file local storage. What is local storage? When multiple people are working, they have their own configuration files. Let's say this particular user is trying to use one AMI and this user is trying to use another AMI and this user is trying to use another AMI, which is a mismatching, right? Everybody has to follow the same thing or only one user has to update the changes, right? So this user is using the same desktop. Let's say this user is also using the same workstation and this user is also using same workstation, but this user is trying to modify some parameter and this user is trying to modify another parameter with a different value and this user is also trying to modify some another value. See, multiple people can log into the Linux operating system, right? So everybody is trying to do some modification. So how come your Terraform state file will understand that how which particular changes to be updated or which changes are there in the target provider, right? So this is something a mismatch which is not at all appropriate way to handle your infrastructure through Terraform. Okay, you should not at all do this. You have to store this particular Terraform state file in a remote location. From the MO diagram, we can see that multiple team members cannot update the infrastructure at a time, as they do not have access to state files of admin user 1. Only admin user 1 has, let's say, a privilege to access this file. So user 2 wants to do something, but he doesn't have the access. User 3 wants to do something, but he doesn't have access to log into this server. Then that is a problem of delivering the, what do you say, the requirement, right, of the client. So that's the reason this approach of storing the state file in the local storage is not an appropriate solution, right? So let us see how we can do that. So for that, let me show you one diagram. So how to solve this problem. Okay. So let us open this. Now for this approach, you can see you are trying to solve the problem. Instead of all the three users are having access to this particular server to run the Terraform commands. But your Terraform state file will not get stored here. It will store in the S3 bucket. Let's say I'm using AWS S3 provider, let's say AWS provider. So I'm using AWS S3 bucket as a service to store my Terraform state file. Okay, since the Terraform state files are stored in a remote storage like S3 bucket shown above, this file will be shared by multiple admin users. Now everybody can access this file and only one user can do the modifications at a time. It's not like another user, admin user 1 only can log into the server, admin 2 and 3 cannot log into the server. Everybody can log in. Now everybody can run the Terraform commands, but your Terraform state file is stored in the remote location. Okay, that's all. Note, if two or more admin users tries to run the Terraform, you may run into a race condition, which leads to conflict, data losses, and state file corruption. Obviously, right? Let's say this user is trying to run some command to apply some change. Parallelly, other user also is trying to run the command. See, multiple process can be created in the operating systems, right? One process is trying to run some Terraform apply command. and this user also, it doesn't know, right, how, when, which user has logged into the system. So another user also logged in, and he did some changes which admin user 1 doesn't know about it, and admin user 3 also doesn't know that there is a process running of Terraform apply. So what this user will do, he will modify the configuration file and he will run the Terraform plan, and then he will run the Terraform apply. So one Terraform apply is already running and it is trying to do some changes. Meanwhile, other user also has run the Terraform apply. So it will conflict. It will do some mess up in your Terraform state file, and the target provider also, first instance will be created with this image ID, and another user has changed it, so it will create with another ID. So whoever has done the last change, that changes will be applied to your target provider, and that changes will be stored in the Terraform TF state file. Okay, so which is like a mess, right? So that should not happen in the real time. Though your Terraform state file is stored in the remote location, but still the problem is multiple users are running with multiple changes in the Terraform configuration files. So your Terraform state file will get messed up, even though if it is stored in the local machine or in the remote location. To overcome this, we are using a state locking. So let me show you the Terraform state locking diagram, how it looks. Yeah. Just a second. State locking, yeah. Now let me show this diagram. Now additionally, we are adding some one more protection to our Terraform state file is, first change is we are trying to store our Terraform state file in a remote location, that is S3 bucket. With that also we have some challenges. To overcome that challenge, we are using DynamoDB state locking. State locking in the sense, one process has tried opening this file, so automatically it will apply a lock to this particular file. Okay, with the help of DynamoDB. Some ID will be created, and that ID will ensure that there is no other process who is trying to open this file. If they try to open, it will give the error message to that particular process, right? So what is the advantage of this? I run some Terraform apply. User 2 or user 3 is trying to run Terraform apply once again from their end. It will log the command. It will throw some error what I've shown you. It will tell you that some other person has already ran the Terraform some command. It will tell you also from which system, what is the IP address, what command they have run. It will tell you in the error message. So from that you will understand that okay, some other person has already initiated some workflow command, so I should not do this right now. Okay, so you will be interacting. So there will be a proper management of this particular Terraform state file, which is really important for a Terraform to maintain the current state of your resources, what has been created on the target provider. So we are using a remote state storage, and we are using state locking to protect our Terraform state file in a proper way for production or whatever it is in the real time. Okay, so till now you have seen the basics. Okay, you understood Terraform state file. It will be stored from where you run the Terraform commands and all. That's fine, but that is not the appropriate approach, right? When you are using in a production or any real-time environment. So you have to see the Terraform state, remote state storage, and state locking. Okay, so that will help you to do this. All state files will be stored in the remote location. Support state locking. Almost whatever the Terraform provide, Terraform has to support this state locking actually. State locking and remote state storage. Okay, if every target provider is providing a remote state storage, then automatically state locking is enabled by default. They also provide that functionality. Okay, that is what the first statement is. State locking happens automatically on all operations performed by Terraform. Even if you run Terraform plan also, it will apply a lock. Terraform plan, Terraform apply, Terraform destroy, Terraform update, everything. It will appear state locking. Okay, state locking failure will block Terraform to continue. If there is a Terraform state locking, if it is trying to apply a locking to that particular state file, if that process is something went wrong, it will not continue with the next step of Terraform apply or Terraform plan or Terraform destroy, Terraform update, whatever it is, it will not proceed further. First, it should apply a locking. Once a lock is applied, then only it should proceed with the Terraform commands. Okay, so automatically program will come to know about it. Terraform command will know about it, and it will, if the locking is not happening, it will not continue with the command. Okay, so that these are the features and these are the functionalities of your Terraform state storage and remote state storage and with state locking. Okay, so I hope you understood all this. These diagrams are already there. You can just click on
Sir,
the links
one
what I
question.
showed. Yeah, Dinesh.
Uh, Sudhir, so how other files will be referred in the TF state file, instance TF and those files? So
Other
those will be
files
in
in
the
the
local,
sense?
right? So we will
Yeah,
be
it's up
having
to
instance
you.
file and
It's up to you. In the best recommendation is you push it to the Git repository, right? You have to
yeah.
test it, and finally to run on dev environment or in production or in staging, it has to go to the Git repository. Any source code, right?
Okay.
Yeah. You will
So
test it
you
in
mean to
your
say
local machine.
all the
Yeah. You will test it in your
yeah,
local
okay,
machine,
got it.
but
Like
once the testing has been passed, you
mm,
will push it to the repository, right? And repository will run the
so
CI/CD
yeah, yeah.
pipeline to apply it. Got it? Okay.
Hello.
Yeah, yeah. So now, backends are responsible for storing state and providing API for state locking. So backend, what are the responsibilities provided by the target provider? They will ensure that there is they provide an API for state locking as well. Okay. So for example, AWS S3 Bucket for Terraform state storage, AWS DynamoDB for Terraform state locking. So we are using these two what do you say resources to apply this Terraform remote state storage and state locking. Okay, so differences between local state file and remote state file is you already know. If you store your local state file in your local machine, that's called as local state. Remote state is if you store it in a remote location, centralized location. Okay, all backends doesn't support state locking. AWS S3 supports state locking, what we are using, and Azure also supports state locking. But sometimes it doesn't mean that all the backends doesn't support a state locking. State locking happens automatically on all operations what we have discussed. If a state locking fails, Terraform will not continue as we discussed. We can disable state locking for most commands with the -lock command. But still, if you want to remove, if you don't want to lock the file, Terraform state file, when you're running some command, you can override that using -lock. Okay, but
Sir,
it is not at all.
sir, sir, I have a question here. See here, so we are talking about locking, right? And for
Yes,
locking, we are taking the help of DynamoDB. So my question is,
yes.
can we do it from Terraform itself instead of taking from DynamoDB?
No, we cannot. Terraform itself is not providing it. In cloud, it is providing you, not in the CLI. Okay. When we
Okay,
discuss
but here
about
we have a
Terraform cloud, right?
hyphen. Uh-huh.
Sorry.
So we cannot do it from Terraform side. We cannot do the locking.
From Terraform CLI, we cannot do it. Okay. We have a Terraform cloud where it has Terraform has its own state logging and state storage in the cloud itself. Okay. From Terraform CLI on the local machine, you cannot do that. Okay.
Yeah, yeah, understood, sir.
Okay. Okay. Now, after this, if you require a log file takes long time than expected, Terraform will output a status message. What happened to that? How long it is taking and all. If Terraform doesn't output a message, state logging is still occurred if your backend supports it. Okay, so Terraform has a force unlock command to manually unlock the state if locking has been failed. Okay, so still we can do that. So let us see one by one how to do that and all. So how to store your Terraform state file in a remote location of S3 bucket in AWS? This is how it is. Okay. So this is the section we need to write, which is another nested block in your Terraform settings block. This is your nested block, like your required provider. Okay. So in this, I'm writing backend is equal to S3 bucket. What is the bucket name? Key in the sense I will tell you what is that, and region, okay, where it has to create that particular bucket, and the state logging is nothing but your DynamoDB. So this is the section which you need to write equal to that particular DynamoDB table name. That's it. Okay. So then Terraform Cloud and Enterprise, we will discuss about that. I don't want to discuss right away. Okay, so when we discuss about Terraform Cloud and Enterprise, always uses their own state storage, which I told you, right, when performing Terraform run. So they ignore any backend blocks in the configuration. If you are using Terraform Cloud, right, okay, and you are trying to push your Terraform configuration files to the remote location by writing this, okay, it will ignore. It will not consider this. Why? Because Terraform Cloud is using its own storage to save the Terraform state file and locking to it. Okay, so you no need to worry about how to store this particular Terraform state file. Cloud will take care of it. Okay, so Terraform Cloud, when we discuss about that, we can see where it will get stored and how to access it, how we can apply state locking. Okay, so for Terraform Cloud users, it is always recommended to use backend block in Terraform configuration for commands like Terraform taint, which can be executed only using Terraform CLI. So we can discuss about this point, few points which you cannot understand right now. Even I say it also, you cannot compare with anything else. Okay. So we have two kinds of backend types. One is enhanced and one is standard. Enhanced backend instance can perform two tasks like store state file and perform operations. So there are, sorry, there is spelling mistake. Let me correct it. Sorry. So there are two enhanced backends, local and remote, which we have talked about right now, right? So Terraform state file can be stored in the local and in the remote. Okay. Example, Terraform Cloud and Terraform Enterprise. That is called as enhanced backend. So standard backend in the sense they are only store state and rely on the local backend for performing operations. What is that? Your state file will be stored in the remote location, but still Terraform configuration files will be there in your local system. That is called a standard backend. Enhanced backend in the sense your Terraform configuration files and your state file will be there in the remote location. That is called as Terraform Cloud and Enterprise. That is the best example for enhanced backend. Okay, so no need to worry like where to push the configuration files in one location, state file in another location. It's not like that. When you use a Terraform Cloud or Enterprise, Terraform configuration file will be stored as a repository in the cloud, Terraform Cloud, and your state file also will be stored in a Terraform Cloud itself in a proper way. Okay, so that is called as enhanced backend. So you can compare these points when we talk about Terraform Cloud. So I don't want to go in depth right now and try to explain you or convince you on these statements. Okay, so Terraform commands for state perspective is Terraform show, refresh, plan, state, force unlock, taint, untaint, Terraform apply target. So these are the commands which we are going to discuss one by one. When to use Terraform show, Terraform refresh, in what situations. Okay, Terraform plan, Terraform state. Terraform plan you already know. Terraform state. In the plan we have some options what we have not seen till now. So Terraform state, force unlock, taint, untaint, and apply target. So these are divided into topics actually. These commands. Okay, so let us discuss that. All the documentation what I'm talking about theoretically here are already referred here. You can always use the official documentation for reference. Okay, so I see in the most of the interviews Terraform is like mandate, like everybody is asking in the DevOps. Okay, or not only in DevOps, if you are using Azure or AWS, Terraform now became mandate in any interview. Okay, so well prepare for that. If you want to change your profile or if you are shifting from a company and all, if you want to change, then this is the tool which you need to learn. Okay, just a note for that. Now let us understand how to apply a Terraform remote state storage, how to do that. So for this, the prerequisite, I have written the steps. Okay, how to create a S3 bucket and how to enable it. So log into the AWS console with your root credentials or IAM user, which you already do regularly, which I used to show, right? So let me do it once again. And let me show you that. Okay, so AWS console, let me log into it. So I want to use IAM user. Okay, Now I need to go for S3 bucket, right? So here I have my favorite services are not there. What? Okay. Anyway, so here you can go to the storage section. These are the storage types we have in AWS, right? So I'm going to S3 bucket. S3 bucket is nothing but a block object storage. So if you want to learn what is object storage and all storage types, okay, you can just read it actually. Uh, there are three types of storages, right? If you click on this statement, oh, is that, yeah, refresh the page. We have object storage, block storage, okay, and file system. So these are the three types of storages actually. Search it, you will get to know what is a object storage. This is what it is we are using right now. Okay, S3 bucket is nothing but object storage. Object storage in the sense it is unstructured data. If you want to store some unstructured data like your videos, photographs, or some particular documentations or some files or anything which if you want to store in an unstructured format, then you can use this object storage called S3 bucket. In Azure it is called as blob storage, BLOB, blob. Okay, so here you have logged in. If you click on buckets, you can say create bucket. Okay, so let's click on create bucket. Now you have to give some name, and this name has to be unique. Okay, and must not contain spaces or uppercase letters. That is what you have to understand. Read this, always try to read the notes below that particular option what you are trying to enable. Okay, so make a habit of that. Okay, so let me try to say like Sudhir, let me give this name, which name I will be using this one, Terraform state file Sudhir. Let me try to give that. You can see it. I think that is a bucket name which I want to give. Yeah, right. After that, I want to create this bucket in this region. Okay, US East 1, same whatever the region I have logged in. So choose bucket if you want to pull the bucket settings from this particular any other bucket which is existing, then you can choose this option. But if you want to set some settings, permissions, nothing but access permissions. So I have blocked all public access. Means if any user is trying to access my object, it will reject. Okay, I need to give some proper permissions for a user to access my object which is stored in this particular bucket. Okay, so later we will see how to change the permissions, but right now let us look into this. So if you want to enable versioning, you need to, but here in my case I will enable the versioning. You can say I've written the point as well. Okay, tags are optional. Okay, if you want to add a tag, you can add like name, Terraform. Okay, this is not mandatory. I don't want to encrypt the data which is stored in the bucket, so you can just ignore this. If you want to see more settings like object locking and all, you can just do it from here. Okay, so then create bucket. So this is permanent locking. Don't imagine that, so why can't we use this locking instead of DynamoDB? That is a different scenario and this is a different scenario. Okay, yeah, now your S3 bucket has been created. Okay, so if you want, you can upload some particular file and you can just see it actually. Go to the inside of the bucket and create some folder if you want some production. Why? Because in the example I'm using like this. Okay, so why? Because in an example I'll be storing under some particular directory. Okay, if not, no need to give. See, it is not mandatory that you need to create some directory. Okay, sorry, some folder. Okay, let me leave that. Okay, leave like that. Okay, under this I need to see my state file stored. Okay, so how will you do it from Terraform? So let us see. So I think somewhere I have created some manifest files. Yes, exactly. So here I created, right? Copy this one. I will explain you. I will not add any state locking to this. I will remove this, but still I have written, I will do some changes as per our current scenario. Okay, state manipulation. Here I will create a directory called remote storage. Okay, so here I want to store. Why? Because there is state locking also, right? So I don't want to club everything. Okay, so you can remove this. Production is not needed, you can just remove. Okay, so we are not doing that. So this one I created, same name, Terraform state files Sudhir. If you go to the my bucket, you can say Terraform state files Sudhir, because I copied from there name. US East 1 as usual. DynamoDB section I will remove right now. Why? Because we are not using that. Okay, and it is going to create an US East 1 region. That is my requirement, and this is the parameter, other parameters which are written as usual. Okay, next, let me run Terraform format to reformat this file. Let me try to give this. Why? Because I'm doing this because I want to store in a proper format in my example files. Let me do it. Sorry guys, if you hear some noise, please ignore. Okay. You know multi-line comments, right, in Terraform? As usual. Let me close the window first. So now let me store this. So I'll push the changes so you can have it. Okay. After that, variables as usual. So we'll be having some variables that we are going to use. So variables.tf file. Let's store this. And you can run Terraform FMT to format this file, because why I'm doing this always, because I want see how I written in my Terraform configuration files in Visual Studio. It's like improper actually. Now save this file and come out. After this, there is one more file, instance, right? So let's take this. For all our state manipulation from now today, we will be using the same example. I don't want to create some complex examples. Let us keep it simple. The main concept is we need to understand this manipulation, how to work with state files. That is the only intent. So don't worry too much. So let me. Right. So now what I need to do? So Terraform plan. Sorry, Terraform init as usual. Some mistake. So after the plugin has been downloaded, then we need to run Terraform validate to see all the parameters what I've written, the schema and everything should be validated. You can see here, successfully configured the bucket S3, sorry, the backend S3. Terraform will automatically use this backend unless the backend configuration changes. For what it will use? It will store the data over here. So initializing the backend, that's what you see. So Terraform has created a log file .terraform. This is the regular statement what you get. But here you can see additionally these are the statement which you see right now. Okay, which you have not seen earlier. Okay, so now additional thing is like if you are used to change the module, this is not needed. Now Terraform validated. Done. So which means that it's fine. Now let me run Terraform plan. See, in the Terraform plan also it doesn't store your file. Okay, only once you do the first time apply, then your state file will be stored. As usual, you already know that Terraform file plan is just a preview. It doesn't create a Terraform state file. Okay, so do remember this point. When your Terraform state file will be created, when you apply your Terraform apply for the first time. Okay, so now this is the plan. I'm okay with this. You can see there is no Terraform state file created here. Now let us apply. So Terraform hyphen auto. Let me use auto hyphen apply. So in my S3 S3 bucket, it has to store my Terraform state file, and the instance has to be created in the US East 1 region. So instance is getting created. Let's go to our dashboard. Here, if I refresh, let me see if a state file is created. Not yet. So let me go to EC2. Anyway, instance will get created. I just want to show you that instance is getting created. Okay, you can see it is in pending, which is like almost it is getting created. Okay, you can see which is still running it. You can see right now it's running. Okay, so let the command finish. I want to show you something. Okay, resource creation has been completed. Now execute ls-al command. Can you see your Terraform state file? No, right? Anywhere, nothing. Even if you have some doubt to execute this tree command, you don't see your Terraform state file. You see only Terraform state file under this. Okay, but what it will have? Now you have some doubt. Okay, you told me that your Terraform state file will be stored in the remote location. Then what about this? Okay, so let me talk about that. So Terraform state file. So it is not showing you any information. It is only telling you that what is the backend you are using and the information of that particular backend. That's it. Is it showing you the resource details and all? No. It is telling you that what you are using the backend to store your Terraform state file. Okay, and that is stored under .terraform directory. Okay, so do remember this. Now let me go to S3 bucket, and I need to see my Terraform state file, right, under my bucket. So if you click on this, now you can see the Terraform state file. If you click on this, you can see the info. Like, let me try to access this file. Okay, you can see the object URL. Let me try to access this. So it will give you a permission denied. Why? Because if you go to the permissions, I gave, let me try to give permissions here on the bucket level, block all public access. Okay, so that's how it is. Okay, so if I try to edit this, if you want to see, only for that reason I'm doing it. Save the changes. It is asking for confirm this. Okay, now if you refresh this, just a second. Now I need to give the permissions here. Whom need to access, what is actions I need to give. We used to do it, right? So let me take some example from there. Where I did it actually, variables, no, from here. Let me take from demo 3. Here it is. Okay. Okay. So what I will show you, what I'm doing. I'm trying to give my bucket a public read access. Okay. So what is my bucket name? Let me do that. If you want to give all the access, that's fine, but Terraform state files -0. So Terraform -state files -0. Okay, that's it. All the files, all the objects under that particular bucket, I'm giving the access. You can see /star. Star in the sense all the objects which are stored under this bucket will have a read access. You can see public read get object. Okay, and now save the changes. So you understood, right? It doesn't mean that if you unblock this particular checkbox, it doesn't mean that you can access. You need to give a proper permissions and tell the S3 bucket that, okay, to whom I need to give the access. So I'm telling that for a public, I need to give a read access. Okay, so if you refresh this, you can see your Terraform state file. Okay, you can see your instance details, okay, which are stored here. What is public IP address, private IP address, you can see here. Private IP, okay, public IP, and all. The device information, everything you can see from here. Okay, so this is how it is. So we don't do it. Let me try to delete this. Okay, only for our convenience, I just added it. So I need to do edit. block the access. Why? Because why you need to access this? Not needed, right? Just we need to store here. That is our requirement. So I give public read. If I try to access the URL once again, if I refresh this, you can see permission denied. Okay, done. So you can understand that this is the state file which is stored. Now if I do some changes, let me do that. Anyway, the state file is not stored here, that you have already understood. So let me go here and or variables. Sorry. Let me go to the variables and let me change the instance state from T2 to T3. Okay, since I added versioning in the S3 bucket, let me show you how the state files will be stored. Okay, so Terraform plan, it will show you that what it is trying to do. It should do an update, not a recreate. As usual, right? You already know this. I don't want to stress once again. Refreshing state file, in the sense it is reading the state file and it is understanding what is there and what is your expectation. So from your expectation is, earlier it is T2 micro, now we are expecting it to T3 micro. So it will do update in place. Okay, simple update in place. It is not a recreate. You can say want to change, not to a destroy. Okay, now Terraform apply hyphen auto auto upload. Let us see how it goes. You can see it is printing the Terraform plan output. Even the apply also will print, right? First it will print the plan and then it will go ahead and it will do as per your option. If you don't provide this, it will prompt you to give yes or no. So let it be done. Done, right? It took 57 seconds. Let me refresh this. Let me open this file. Okay, did I added versioning on this? Yeah, here you can see versions. Now you see two files. So always see, this is the latest file, current version. You can see current version in the sense this file has the latest changes. Okay, and this file is backed up in the sense previously it has some data, now the data has been changed, so that's the reason it took a versioning in the sense it will add a timestamp and it will store as a new id with a new id, this file. So if you want to download this file, click on this and you can download. Okay, or if you want to open, you can do that. Okay, so this file will have information related to T3 micro, what you did right now. So this file will have a T2 micro. Why? Because you did some change, right? So everything will be stored here. So that's the reason of why I enabled versioning. The reason is because of this. Okay, you will see only one file here. Obviously, you will see only one file. But if you click on that particular file, you will see your versions of this particular file. Okay, so which one you want to restore, that you can just click and you can download or you can do whatever you want. Okay, so that's how it is. Okay, so this is how we store our Terraform state files, which is called as key. Storing the files in the, we call it as objects, or we call it also call it as keys. Okay, key in the S3 bucket. Okay, you can see the size of the file. Okay, type is tf state, means the extension. Okay, and the key is this, means the file. Okay, permissions and all, if you want to add and all, you can do it. So right now we are not doing anything related to permissions. Why? Because we don't want to allow this particular file to be accessed from outside, right? So that's the reason. Okay, So this is how it is. So if you have any questions, we can start discussing about it, or else we can wind up this. So yeah, any questions? No?
No, Sudhir.
Okay.
No,
Yeah, I
no.
will not delete
So
this,
we'll
or let me try to delete. I don't want to delete. Let it be like that. Okay, I created only one bucket and stored one file, right? Let it be like that. So we'll continue tomorrow, but let me try to destroy this. So if you do a destroy, there will be one more version file which will be created. Let's see that. Just only a few minutes, 1 or 2 minutes it will take, because
about the
whenever
backup file or
resource, it will destroy your instance, right? Not your file. It will delete the resource. Okay. Because
but
your
it will
S3
create
bucket is
on.
not managed by your Terraform. Okay, I
It
created it
will.
manually.
Okay, okay. It will create. I mean, it will
Another
delete the
version file,
It will delete the instance and it will
obviously.
create one backup file, right?
Yes.
Leave it.
So it will create one more version file. Let us see that. Let me refresh. I think it will take some time. Just wait. Once it is done,
Okay.
then you can see it.
Another version of
Because there
file
are
will
three
be created.
changes. Sorry.
Sorry. Another version of file will be created in the S3 bucket itself, right? Those files.
Yes. Yes. Exactly. Why? Because totally we did three changes. So three state versioning files will be there. Like your commit, which we do in Git, right? Similar to that. Every commit will have some changes. So here it is called as versioning. For every version, it will have some ID. You can call it as like commit ID or version ID, whatever it is. Yeah, done, right? So let me refresh. You will see it. Okay. Now it is only 155 bytes. See the size, because it doesn't have any data. Okay. Hope you've seen this and understood. So let us continue. Tomorrow, shall we have a session or directly on Monday? If you want to practice, I will not conduct. If you want a session, then I will conduct tomorrow.
We will have on Monday. We'll practice.
Yeah, we need.
Okay.
Yeah, even I need time to practice. Yeah.
Okay then. Yeah. Thank you.
Thank you.
Thanks.